This week we're going to talk about one of my favorite subjects in meteorology, and that's thunderstorms. I'm always trying to figure out why one will form or why it's more intense in one area than another, and it's just not something that we know everything about. We know a lot more than we used to, but we're still learning all the time. So with that, let's take a look at the thunderstorms. We're going to talk about the conditions that allow thunderstorms to form and why they may become severe. But first, let's look at what is a thunderstorm. We've talked about stability and vertical motion. So if you have a parcel of air, in this case, the size of a cumulus cloud, it's rising upward. That parcel of air is warmer than its surrounding. It's unstable. So it continues to rise and might even, remember stability, the more unstable, the more acceleration there is to the air parcel. So it goes faster and faster upwards. So you get to the mature stage. Mature stage, you're going to have some of that air is going to start coming back down because it's going to get condensation in it. It's going to grow raindrops in it. All of these are cooling mechanisms. So this air on this side is going to become cooler and begins to drop down, hit back down to the ground, pouring down the rain. But you'll notice there's tremendous amount of warm, moist air being pulled in here and the cool gust front air down here. Notice how they go out on each side here, that gust front. If that gust front gets out here where it's blocking off this warm air from coming in, that thunderstorm can no longer grow. And you'll notice the dissipation phase where that has been happened. It cut it off and it's all stable air sinking. Thunderstorms can form as a single individual storm. We get those all the time in the summertime. You get one different locations, and I can't even begin to tell you why that one particular thunderstorm might form over that ball field while it didn't form at your house. It's just not in the science at this moment. We get multi-cluster storms where you have several thunderstorms together and they're working kind of working together to keep themselves growing. You'll find thunderstorms in different parts of development in a multi-cell cluster. Some will be just forming, some will be at the mature stage, some will be at dissipation. In multi-cell line, you have again, it's just like a squall line forming along a cold front. And then you can have these intense supercells where that gust front never gets out in front enough to cut off that warm air. And what you wind up with is intense rising motion that just continues to last. These can last hours in time, whereas most single cells might be 20 to 30 minutes long. So here is what a multi-cell looks like. You have a new storm forming, it matures, and eventually dissipates. And it does that along this path line, we'll say. But the actual motion of the storms is to the right. So you can see here, cell movement is one way, but the actual storms are moving another way. So what are you looking for? You're looking for maritime tropical air. You want to have something to destabilize the air, some form of lift to get that air moving. It is not always going to be just the sun that makes it move. Maybe a cold front, maybe a warm front, maybe mountains. So the more solar heating, however, the hotter you can get that low-level air, the higher the chances are that it's going to really get lifted. And you can see here where they typically form. Most predominant place for thunderstorms is down in Florida, southwest coast. And why do they form down there? Because it's almost always in a maritime tropical air mass. And you have sea breeze from the Gulf, sea breeze from the Atlantic. And we've talked about convergence and how that lifts air up. So that's where your air is rising. And what do you wind up with? Is thunderstorms. And they can, depending on which one is stronger, the sea breeze from the Gulf may be stronger one day. The sea breeze from the Atlantic may be stronger another day, is where they'll form in that peninsula. So vertical wind shear really is one of the dictates of what causes severe weather and thunderstorms. The stronger your wind shear, the better chance you're going to have severe weather in a thunderstorm. So Here's a classic situation that happens in the Southwest, where you have very strong low-level jet, probably at about 5,000 feet, coming out of the due south. Underneath that, you have moisture coming in off the Gulf of Mexico, very humid maritime tropical air. You might even have some dry continental tropical air coming in here. Here you have a jet stream. Look how it crosses that. There is tremendous wind shear right there. And that is the area with that wind shear that's going to cause rotation and going to cause severe weather, potentially tornadoes. Another thing that helps many of the Midwest, you get a stable layer that develops. That stable layer allows the low-level air to warm up. You don't even get any clouds because of that layer, so that by late afternoon, the temperature is warmed significantly, and you wind up with a better chance of stronger convection. Lightning is an issue in thunderstorms. Why is it? What happens to cause lightning? Lightning is formed by a small ice crystal and grapple combining. Grapple is just a little bit ice crystal and water kind of mixed together. So a little bit larger. And guess what? The charge of grapple changes depending on the temperature. And so does the charge of an ice crystal. So if the temperature is less than 5 degrees Fahrenheit, probably in the upper part of the cloud, right? Grapple is going to be negatively charged. The ice crystals are going to be positively charged. You flip them if the temperature is greater down in the low level. So what happens? You wind up with more positive and negative charge up here. Middle level, a lot of negative. Down on the ground, the positive here. And you wind up with lightning. It can go here, and it can work its all the way up to the very top. And eventually, the strongest charge will probably be a positive charge coming down to the ground as it works its way down. So that's how lightning is formed, by separation of charges due to grapple and ice crystals changing charge, being opposite charge anyways, and then changing their charge depending on air temperature. One of the things, you will not have lightning in a thunderstorm unless the temperature is below freezing. You must have ice crystals there to cause lightning. So in the summertime, sometimes you can get a very hot, humid air mass that really pours the rain, but you never see any lightning. The reason why is the top of that cloud never got cold enough to be that cold. Another hazard is microburst or downburst. Think about it if you're an airplane. If you're an airplane, you're flying into having great headwind, it's going to help your lift. All of a sudden, you have a very big tailwind, going to push you down. There have been way too many accidents over the years where aircraft have come into these situations and couldn't react in time because there can be extreme changes in wind speed there. Derechos are just long-term echoes. They last for hours. There have been some that went through Ohio that lasted for many, many hours. Many of them formed up in Chicago area or in the Midwest and then just tracked east. You might get them late in the afternoon, late in the evening. Some have even formed and moved on across to the southeast. This is one that occurred in 2018. Flash floods are a thing. Think about it. All that moisture, maritime tropical air, getting pushed into a small area, tremendous rainfall event can occur. Some of the worst flash flooding was the Big Thompson Canyon. I actually lost a friend in that flooding. Other Fort Collins, Colorado was another one. They can occur in your area, so be watchful of them. Did you know that less than a half a foot of water, moving water, can move your car? So think about that when you're driving through water on the road in a flash flood situation. If you're going across where you think there might be a creek and that water is moving, you only need a half a foot to take your car off the road and over the bridge. Hail, it's just frozen liquid bumped to get clustered together. It's kind of where you see that air parcels were going up in one part of the thunderstorm and down in the other. Well, when they come together and go back and forth there, they're getting moisture from below, re-icing, going back down. Eventually, they get so big that they do hit the ground. And you can see here the Weather Service categorizes them by pennies, nickels, mothballs. 1-inch hail is considered severe. Used to be 3/4, but now it's 1 inch. So you can see hail forms in the mid part of the clouds and gradually descends and ends. Tornadoes, it's the most violent weather on Earth. There are always some that form. About 10% of the annual 10,000 severe thunderstorms are tornadoes. They're usually short-lived. They usually don't strike even populated areas. One of the interesting things about a weak tornadoes don't like mountains, don't like hills even. They like flatland. However, a violent or very strong tornado, it doesn't care. So you can have hills or mountains around, and if you have a violent, an EF2 or greater tornado, it is not going to care about that one bit. There are areas that have more tornadoes than others. You can see here, Ohio averages 19 tornadoes and 5 major ones over 1,000 square miles by state in the last so many years. That's actually a fairly significant amount. You look at the others around you, Florida has 10, 11 in Kansas, 9 in Oklahoma. At 5 major tornadoes, that's pretty significant. Here was one of those examples of a tornado. And tornadoes don't always have the same intensity. This started out as an EF0, became an EF5, and then moved on east. This tornado actually had 50 minutes of lead time in downtown Joplin. And that 50 minutes caused some people to come outside where they were sheltering, believing the storm was over, and then drive right into the middle of the tornado. So the question is, how long is too long for warnings for tornadoes? And there is the enhanced Fujita scale. Here is another classic where the tornado is wrapped around, and you can see a wall cloud usually first, very flat cloud. That's very distinguishable from where they're kind of rolling on other severe. Rotation may be spotted in it. A gradually tornado forms and it gradually will dissipate. Here is just an example. You can see the hook echo, and here's your tornado. And since we have it going today, I wanted to quickly, and I will emphasize quickly, go through an event that is occurring right now in western part of Ohio. We have a squall line to the west. Why do we have that squall line to the west? There's a strong cold front there moving through. However, dew points are in the 60s and coming upwards. Southerly wind temperatures are in the 40s and 30s to the west of that front. So if you look at the current, just look, for example, at moisture convergence. It's the area strongest convergence of moisture. It's right along that squall line showing up right here. Another thing to think about, we talk about stability. There's a measure of stability called CAPE, convective available potential energy. Notice how it's up over 2,500. That's getting pretty strong. So that's one reason why this area was put in a severe thunderstorm watch today. Another is wind shear. Effective wind shear. You want at least 40 knots. And notice here, across parts of that area, are 40 knots or greater, 30 to 40 knots, and some even 45 knots of wind here. A very strong wind shear. So there is a chance for significant thunderstorms there. But the chance is mainly, looking at what Storm Prediction Center says, it's mainly a chance of hail and strong downburst. Not too much likelihood of tornadoes, and really not that much chance of hail today. So just applying everything we learned, and you can even look at it on the ghost sector, and you can see all the cumulus clouds forming, and you can see the squall line right along it. So hope you got something out of this. Let me know if you have any questions at all.